Welcome to the 2020-2021 Junior Topic 2 for the WRDSB Math Long Range Plan Just-in-Time PD session. This is a recording that we have made after our session, just to make an overview of it available for people. We did have another glitch with our recording of the main session, so we are going to make one for you right now. That'll have all the content that was discussed in our session for topic 2. So without any further ado, we are going to go ahead with presentation. The land acknowledgement is an act of reconciliation that involves making a statement, recognizing the traditional territory of Indigenous people who called the land home before the arrival of settlers, and in many cases still do call it home. The official WRDSB statement, read at the start of meetings and in school announcements, references the deep traditional knowledge, laws, and philosophies of Indigenous cultures. Take a moment to look at and reflect on this artwork by Bruce Beardy, depicting the ongoing journey of an educator. Bruce is an educator in Ontario who is part of OCT. One of the things I notice in this depiction, this work of art, is the winding nature of the path, our journey. I noticed how a path can lead us in unexpected directions, with new encounters, winding through challenges and discoveries. We would like to begin by acknowledging that the land on which we gather today is the traditional land used by the Haudenosaunee and Anishinaabe and Neutral peoples. We also acknowledge the enduring presence and deep traditional knowledge, laws, and philosophies of the Indigenous people with whom we share the land today. This is our teaching and learning support staff team that are working on the math long range plans for you. In junior is myself and Conrad. We are here for this session today, looking at topic 2. Right now, in primary, Virginia, John, and Lindsay are running that session for topic 2, and in intermediate, Rhonda and Michelle are running that for topic 2 as well. Thank you for taking the time to join us today. We understand you are all very busy. Thank you for popping in to watch this video. Our intention is to press pause for a moment, dig into some math ideas for topic 2. And we've timed this, as we call it, just in time session, so that we can give you exactly what you need and when you need it. We're hopeful that taking time to watch this video will pay off as you teach each topic. Today's agenda is going to cover the big ideas in topic 2, grade 4 through 6. We're going to look at what has changed in the 2020 curriculum. We're also going to share some graphical representations in grade 4-5 breakout session, and in our grade 6 session, we're going to look at the linear expression side of patterns. And then we're going to do this through exploring some learning experiences we've done together. So, and then at the end, we're going to address some questions from our Slido poll. Start off with our big ideas here is that we're working with patterns through all the junior grades. You'll notice in our long range plans, we are just at this point here, we're about to enter into the topic 2. One of the things we want to emphasize here is that people are at very different places along this path. And we are not expecting your pacing to be the same. We are not saying we are all exactly at this point in the path. We are all on the same path. What's important is that we're focused on taking the same path rather than worrying about being at the same pace, because we know that our students, our classrooms are very different, and we need to differentiate to the needs of our students. So if, for example, 5 new students join my face-to-face class today, or as 5 move into a distance learning class, those 5 students haven't worked on 5 to 10 very different topics in math. So even if they aren't all at the exact same point along the pathway, we're all, the group and all of us, we're moving along the same aligned path of learning. So it makes those transitions much more manageable for you. So we're going to jump into some of those ideas that we want to focus on working with patterns with Conrad next.
So the main change in this topic from the 2005 curriculum is that representing patterns in a graph has been included across grades 4 to 6, instead of previously where it was introduced only in grade 6. Additionally, working with linear growing patterns, as well as their algebraic expressions, has also been moved forward to grade 6 from grade 7 where it was previously taught. We can think about the learning across the primary grades as students becoming familiar with what makes a pattern and determining whether something is a pattern or not by using a variety of representations like movement patterns, sound patterns, shape patterns, and patterns involving letters and numbers. This is also where students first encounter the concept of a pattern rule, the idea that every pattern has to start somewhere and something must repeat. Later in primary, this repeating element sometimes becomes adding or subtracting the same amount over and over again in growing or shrinking patterns. In grade 3, students now first run into the concept of term numbers and term values in growing patterns, which was previously started in grade 4. They naturally start representing this understanding in a table of values, and labeling our concrete representations with these term numbers becomes very, very important for our work with patterns from then on. Across the junior grades, we're working to expand that set of representations that were started in the primary grades without forgetting about the importance of those concrete representations using tiles or cubes. In fact, those concrete representations in tiles or cubes or drawings become fundamental to our understanding of linear growing patterns when they're introduced in grade 6. We also begin looking at graphs of patterns to see what new information they can tell us, as well as comparing more than one pattern as they grow or shrink. Across the division, we're working towards the goal of algebraic reasoning and the ability to generalize patterns and predict far future terms. A big part of these representations, helping to lead students towards generalizing patterns across the division, is related to that evolution of the pattern rule. We start thinking about pattern rules additively in the primary division. For example, start at 2 and add 2 each time. This kind of gives students a snapshot of what's happening term to term in a pattern, but it doesn't give them a sense of the pattern overall or how to generalize it. Going back to concrete representations and really analyzing what's happening as a pattern grows with students can be the key to moving towards a more multiplicative form of pattern rule, like the pattern starts with one group of 2, then expands to 2 groups of 2, then to 3 groups of 2. This can then lead students into a general term in words like the number of tiles in any term is the term number times 2, and eventually into algebraic representations of rules like y equals 2n. This progression of how students think about patterns brings us to the big difference between extending patterns and making and justifying predictions about patterns. This was a question that was posted in the Slido, so we'll address it directly. Extending can be useful to calculate the value of the next few terms, but it usually doesn't move students towards generalizing a pattern. We think about it in additive terms and moving term to term and going down the table, either adding or subtracting each time. Predicting a far future term or any future term can help students to see the value in generalizing a pattern's growth. If I, as a student, am seeking out what's repeating within a pattern's term value in a concrete way, I'll start to get used to that aha moment of seeing it and just how easily that allows me to predict any term. For example, if term 1 is composed of 1 set of 2, term 2 is 2 sets of 2, and term 3 is 3 sets of 2, I should start to feel comfortable predicting that term 100 will be composed of 100 groups of 2 tiles. And I can actually see that picture in my mind. This is very similar to any time that we're hoping to lead students towards generalizing in math. First, we notice something broad, like 5 times 2 is the same as 2 times 5. Then we make a conjecture or a prediction that we believe it's true all the time. Then we might test if it's a sometimes or always scenario with some other cases, like discovering that 5 times 3 is also the same as 3 times 5. Then we dig deeper into understanding the why behind that generalization. That's where the concept of multiplication as arrays really helps us visualize and internalize that rule. My explanation of proof for that rule would be much different once I understood multiplication as arrays. This brought us to the point in our session where we broke off into breakout rooms by grade. The advantage with this recording is that you're able to check out both. I would say there's definitely lots to be gleaned from the grade 4 and 5 focus, even if you are a grade 6 teacher. And the grade 6 focus gets into the nitty-gritty of linear growing patterns and algebraic expressions. So this focus on linear growing patterns is interesting because students' work in grade 6 isn't limited to only these patterns. We're more so highlighting this special type of pattern and working more deeply with them. The why behind that is because this is a special type of pattern that always grows by the same amount. So it grows by a consistent amount every term. It's not one of those patterns where it doubles each term, or one of those patterns where add 2 and add 2 more each time as you move forward. Those patterns are nonlinear, and we still want students to run into those because it will help with their definition of what a linear pattern is, these non-examples of patterns. So early on, when we're kind of getting a definition with students about what a linear growing pattern is, introducing or coming across some of those non-linear patterns is actually a good thing. And this special attribute of linear patterns means that they're sort of super generalizable. It makes a really nice straight line when it's graphed that you can extend further. It can be represented by a simple, consistent pattern rule that has a real structure to it. And it's a generalized pattern rule. It isn't an additive pattern rule. And then eventually an algebraic expression that's simple enough for students to work with algebraically in this grade as well. So there's something unique about this being students' first foray into the connection between algebra and patterning. And it's always sat in the algebra strand. And in primary and junior, we've always kind of wondered why. And it hasn't come up really until intermediate. But that's the why, is that patterning at its core is meant to be algebraic reasoning. So up until now, we've been helping students recognize and distinguish between patterns and non-patterns. And now we're helping students distinguish between linear growing patterns and nonlinear growing patterns. And the why they care that it's a different kind of pattern is that it's so familiar and easier to work with than nonlinear patterns. So we're really used to these additive pattern rules from the primary grades where you start at 2 and you add 2 each time. And those are great for giving me a definition of what makes a pattern and for extending. But it's important for us to think about the type of pattern rules that we're introducing students to and that we're kind of pushing them towards. We want to direct students towards a pattern rule here, and we want to focus on pattern rules in words early on. Ones that help them generalize the pattern and that aren't just for extending. So this example of term value equals something times term number is called a multiplicative pattern rule. And it's a specific type of linear growing pattern that doesn't have a constant in it yet. So it just has its change, and its change is actually the same place where it starts. So you'll notice we have a pattern that goes 2, 4, 6. The part that makes it a multiplicative pattern rule is that it starts at 2 and it grows by 2. We have 5, 10, 15. What makes it multiplicative is that it starts at 5 and it grows by 5. So you can imagine these are very specific and niche patterns. This isn't the rule for all linear growing patterns, but it's a good place to start because it lets us just think about how that pattern's growing. So we're looking in our representations for what is the unit or group that gets repeated from term to term. In term 1, there should be 1 of them. In term 2, there should be 2 of them. Term 3, there should be 3 of them, because that allows me as a student to think about term anything. Term 100, there will be 100 of them, whatever they are. There will be 100 5s, there will be 100 2s, and I can calculate the value from that. But more importantly, I can think about it in terms of that unit. And that whatever that unit is what gets plugged in as term value equals blank times term number. So if the unit is a bunch of 2s, it's 2 times term number. If the unit is a bunch of 5s, it's 5 times term number. Kind of official term for that number is the multiplier. And it becomes a variable eventually in our algebraic equation. But the multiplier affects how quickly a pattern grows. So the bigger the multiplier, the faster a pattern grows because it's getting a larger chunk added on each time. That's the number you would be adding on each term down a table or across a list of numbers. It ends up being a multiplier because there are going to be a whole bunch of them. If I'm adding 2 every time, those 2s are going to start to stack up as my pattern grows. If I add 5 each time, those 5s are going to start stacking up as my pattern grows. In this really friendly version, this multiplicative pattern, they stack up without anything else involved. There's just 2s and there's just 5s. Later on, there's another component. But this is a good place to start with students. And again, that pattern rule in words is just the way I would describe what's happening, right? So the number of tiles or the number of squares is 2 times the term number, or the term number times 2, because it's a bunch of 2s. However, whichever order students want to say it in, I would really want to value that. And I would even want to highlight differences in opinion and preference in the way I word that pattern rule as a student. We want to say that it isn't important the exact way you say it, as long as it is true about the pattern and helps us to generalize moving forward. So we're going to jump into a sample task, get you to mess with some tiles. We thought that we got a lot of feedback in the Slido poll this time that teachers were looking for something a bit more usable with students right away. So we ended up putting our tasks this time just in Google Slides. So if you go to that bit.ly, I'll pop it in the chat so you can maybe just click on it. You should be prompted to make a copy of a slide deck, and then that copy just becomes your copy of the slides that you can mess around with as you wish. There's an almost infinite copy of each tile in the slide, and you're able to pull them and drag them, and they should click together, and you can build term 1, term 2, term 3, and then predict term 10. The prompt is build the first 3 terms in a pattern that follows the rule, number of tiles equals term number times something. So again, we're looking for a multiplicative pattern rule here. It should start at the same spot where it's growing. And then predicting that 10th term and thinking about how might a student explain that in words. So everyone just take a minute. If you have any questions or comments while you're working away, pop them in the chat. But I will give you a moment to try that out and try to picture it from a student perspective. This wouldn't be the first task we would engage with in a patterning learning cycle, but it would be one of the first ones where we're introducing what makes a linear pattern a linear pattern. I'm just going to pop in quickly here to give a short summary of our discussion after the group came back together from this interactive task. We were talking about how representing in tiles could help students see things about patterns and what challenges we anticipated for students using this tool either digitally or concretely, as well as using it in this way. We discussed how this might help students quickly see the number the pattern's growing by, that it would allow them to use color to show change in growth by using different colors of tiles. Not including a gap between groupings of tiles we thought might make things more challenging in each term. We want to model this for students and really walk them through that process and discuss how it helps and why that's a beneficial way to represent. Using more than one color is also another way to maybe highlight those groupings within a term. And we talked about fine motor challenges of using tiles in Google Slides, the idea of clicking and dragging these tiles and making sure they line up perfectly might be one more layer of challenge on top of the thinking that's already going on. Other online alternatives are available in the session resources, but they would require students to screenshot in order to share that thinking. So there is another layer there as well. Students can also work just with a grid here and color in tiles as they wish, either digitally or on paper as another option. All right, so as I keep saying, these multiplicative pattern rules are not the only type of linear growing pattern that we have to deal with. There's also a composite pattern rule, and this is where it has a multiplier. It does involve that multiplicative growth, but it also involves a constant. So this is most patterns. Most patterns don't happen to start in the exact same place, but they're also is the pace they're growing at. This would be a good thing to illustrate for students, that those ones that didn't have a constant, those were kind of a special case, and we're not going to come across those very often. Things don't start at the bottom too often. So where the multiplier was affecting how quickly a pattern grows, the constant's affecting where it starts. So if you think about a graph, that would be how high up your diagonal line is starting along the y-axis. If you think about a table of values, it would just be starting at a higher number for term 1. And if you think about tiles, it would just be a larger pile of tiles in term 1. A larger pile of tiles in term 1 doesn't mean we're growing by a larger amount. Those are kind of two separate pieces to think about when we're looking at linear patterns. Now we can visualize these patterns by thinking about what repeats from term to term, but also we can think about them in terms of what stays the same. So that constant, that thing that affects where they start, that's the piece that's going to be the same across all of them, kind of sitting in the bottom unaffected by the change. And then what's changing, what's growing, that can hopefully be the change that sits separate from the constant that decides where we start. So I have two kind of example patterns here, and they're really similar to the ones we looked at for multiplicative rules. So instead of a 2, 4, 6 pattern, we have a 5, 7, 9 pattern. It's growing the same way. It just started at a different place. It started at 5 instead of right at 2. So because it started at 5 and it's growing by 2, there's actually a 3 that sits at the bottom of each of those changes. Now, the tricky thing is, instinctually, students want to say every time that the constant must be 5 because that's where it starts, right? So this constant affects where it starts, but term 1 already has that multiplier in it. If this is a rule that's going to be true for all terms, it has to also be true for term 1. And that's the tricky thing. We've been used to term 1 sitting outside of our change. It's just where we started. It wasn't a part of the growth, right? And now term 1 is a part of that general rule. So whatever's true for term 2 has to also be true for term 1. And that can be a good way for students to make a prediction or a conjecture and then test it. So again, here it's term value equals 2 times term number. I can see that, but it's also has a +3. So to shift it all up to 5, 7, 9, we had to add 3 to each term calculation. And the other one is term value equals 5 times the term number. So we're still thinking in chunks of 5. But this time it's starting at 7, 12, 17. So I can kind of maybe instinctually see, if I know my skip counting, that it's starting 2 ahead of where it should be if we're just skip counting by 5s, right? And starting at 5s. So these composite rules, we'll try another task. This one's a little bit further along in the learning cycle for students. You certainly wouldn't want to do it before engaging with some multiplicative pattern rules. And it's even further along from an introduction to composite pattern rules. We're already kind of get how they work, and we're looking at a pattern that is presented to us visually but doesn't have a color coding to it. So the ones you saw on the previous slide that had that constant pulled out by color and was really clearly defined as a constant that wasn't affecting the growth and the multiplier that is. In this case, your visual pattern isn't really showing you that. You have to kind of deduce it and figure it out. So I'll let you go through to that. I'll pop bit.ly in the chat. And feel free to pop any thoughts or comments or questions into the chat or through your mic as you're experimenting and exploring there. The text boxes might work better as a conversation rather than being this assignment that has text boxes that I have to fill in. If I were to follow up with a student about their work kind of building term 4, I would want that to be the basis of our conversation. Again, popping in here to give a brief summary of the group's discussion after we came back together after engaging with this interactive task. Here we were talking about, again, how representing in tiles might help students discover a pattern rule this time, and what we anticipated as challenges for students in making this leap from representing a pattern to representing a pattern rule in words. We talked about helping students to notice and seek out the parts of a visual pattern that are changing compared to the parts that are staying the same over time, and how this would be challenging for them to come across on their own. The importance of highlighting these parts in different colors and examining patterns together before trying to move students towards finding these parts themselves in visual representations. Really modeling and encouraging this thinking in students as beneficial and as a powerful way to generalize a pattern. We discussed celebrating and allowing many different ways to word and explain pattern rules in words, such as groups of 2 in the center that are growing and 4 around the outside that always stay the same. And we also talked about the idea of students recording these term values somewhere. So should they be using a table of values here? The idea that students might want to jot down these values of each term when they're working with a visual pattern by counting up the tiles and recording it somewhere. And we might also encourage them to organize it in a table of values, because representing the same pattern in multiple ways can help us to look at them from a different angle. What we might not notice about a pattern in its concrete representation, we might notice when we represent it in a table of values. A table of values also becomes useful because then it would be easy to translate it onto a graph as well and see what we could see about the pattern in that format. Okay, so that brings us to connecting these concrete representations into tables of values and graphs, which we kind of touched on a little bit. So here's a pattern. It's 3, 6, 9. It starts at 3 and it's growing by 3. It's one of those multiplicative ones. And if we rearrange it and kind of stack them together, we can start thinking about what a graph means for a pattern. So you can see along the x-axis, we've labeled our term numbers, and that's what the x-axis always represents when graphing a pattern. X-axis represents our term numbers. This is something that's been in grade 6 for a while, but it's kind of lacked its purpose a little bit. It's always kind of been, but why? And now that we also have linear growing patterns, it really gives us a why. There's something about that graph of those patterns that's super special. And so once that's there, then we start thinking about the y-axis, and that's how much it's worth. So we're just labeling how many tiles each term has there, and maybe with a dot above each one. And then we progress to thinking about a table of values where we have term 1, term 2, term 3, and how much they're worth. And that term number and term value then are transformed into an x value and a y value. So where along the x-axis is which term it is. The further along you go, the further along in the pattern it is. And along the y-axis is how much that term is worth, what its value is in tiles or whatever you're counting in. And that generates some ordered pairs. So from a table of values, you kind of naturally get these ordered pairs that are graphable. And then if it is a linear pattern, you do also get a straight line that connects all of those points. So that's a quick and easy way to check. If my pattern is growing in a predictable and consistent way every term, then it will be connected by a straight line. Now, plotting on a graph, as students get more comfortable with this ordered pair generation and finding its location on a grid, that's something new as well, X and Y values. The Desmos graphing calculator can become a pretty valuable tool. It's available at desmos.com/calculator, and it lets us enter in ordered pairs. It lets us enter in equations once we get there algebraically, and it lets you actually enter entire tables of values, and it would plot all of those points along the grid. So you can see that it wouldn't be the first place you'd want to go. We want to work on pulling the ordered pairs and graphing the ordered pairs using their X and Y values first. But in terms of always having to do that, it might make sense to move towards this digital graphing tool as we go. And there's a scale you can zoom in and out. You can go further along your pattern. Let me just quickly show you a quick little rundown. So this is Desmos. Again, you're given an X and Y axis, and you can kind of click and drag. It does have other quadrants in it, so it's good for students to know that they exist and they will be usable in the future. We won't be using it in grade 6. So at that point, you can start entering in ordered pairs. So if I want to say term 1 is worth 2, 2 is worth 4, 3 is worth 6. Starts to graph my ordered pairs. If I would prefer to use a table of values, that button is here, the plus button, table. Again, it's just graphing them over my other points. And in the table, you can change the settings so it has a solid line. And on top of it all, you can also enter in an equation, and it will graph the line for you. So lots to explore there. At its core, you can enter in ordered pairs and it will place them, and you can zoom in and out on them, thinking about where that line might fall. And I don't think we have time to explore this task. It was going to be a graphing one to explore Desmos, but feel free to try it on your own and reach out to me if you have any questions or comments about how it went. All the tasks are available in our shared folder that we're sharing at the end anyways. Because I do want to get to this piece before we get back into the main room. So, algebraic expressions. This algebraic expression is scary, and everyone from middle school and high school math has a relationship with it. It usually isn't a positive one. I would save it as the last piece for this puzzle. I would say we're talking about term value and multiplier and term number and constant long before we're ever calling it y equals mx plus b. When they become variables, they tend to kind of lose their meaning and become this gobbledygook. If we can keep it meaningful and concrete until near the end of a learning cycle, then we maybe give it its variable labels. Again, if you're solving for a value, a term value, you would be plugging in what term it is. So term 25 would be something times 25 plus whatever your constant is. And if you're solving for a value of 22, it becomes a little bit trickier. So that's where we might be pushing the boundaries of their algebraic abilities, where we're plugging in a value on the left side of the equation and trying to kind of work it out over here. I would leverage the skills they have, guess and check, try a different representation of the pattern and see if we get an estimate of where it might be, and then start plugging in some values. I wouldn't push too hard to be able to solve upfront a term value of 22, let's say. Any questions about algebraic expressions? I know we had to rush through it. We've got to get back to the main room. I'm getting texts. Again, reach out by email if you have any questions about this stuff as you get into it. Sometimes we don't even know how it's going to go until we dig into it with students, right? So it's hard to predict what the questions will be.
All right, welcome to our breakout group for grade 4-5 for our topic 2, patterning. We're going to do some activities together today looking at representations of patterns. The big ideas in grade 5 discussed earlier are essentially table of values, graphing, shrinking. So there's kind of breaking it down. So grade 4 5s are required to show patterns in a table of values and graphs, which are new to our curriculum. And then grade 5s have this added bit where they also look at shrinking patterns, which is probably not a stretch because teachers in the past probably, you know, as you teach, it just makes sense to extend that a little bit and look at growing and shrinking patterns, even though the curriculum has limited to growing. So now grade 5s are extended to shrinking. All right, let's jump in here. One of the big things we want to look at with patterns is that we want to have that open-ended discussion at the beginning of our unit to just discuss how we determine a pattern is a pattern as opposed to a non-pattern. Use contextual situations from real life. And have that open-ended discussion that, you know, will help students think deeply about patterns. There are patterns in our, you know, natural world that at times would seem randomized because of the complexity of the pattern. And then there are patterns that are truly not patterns and randomized. So those discussions are great to have. It's a great way to have a kind of a minds-on kind of a connection schema point for students to get into patterns as opposed to just jumping in and it being arbitrary and disconnected, kind of floating in their world of experience. So when we have these discussions, it helps us kind of start to define things. And also the important part of having these discussions is really that we can start to get at these key attributes of patterns. You know, early on, one of the early things in even primary that we recognize about patterns is the idea of repetition. We see repetition, we see a pattern, right? Patterns in seasons, patterns in, you know, times and weeks. These contextual situations where things repeat are patterns. So we go from there, and then we kind of add on as we get into junior. We're not just looking at repetition necessarily, but also this idea that things grow and extend in a predictable way. So predictability becomes part of patterns. So these are very important attributes that students need to have that connection that in the back of their head when they're engaging with patterns. So speaking of engaging with some tasks, we have a slide link that you're going to click on. We're going to jump into your own slide and you're going to engage with this prompt. Create a model that represents the growing pattern in the table of values shown. How is your pattern growing? So we've got these movable tiles, sorry, that you're going to use. You're going to create some arrangement that represents the table of values that is given. We'll give you some time to do that, and we'll come back and discuss together. Okay, so we're going to wrap up your few minutes of engaging with that task of arranging your tiles. We discussed some of the ideas that came and how you might arrange these and why it makes sense to arrange it that, and even talking about how you would use the various colors. What was the point of changing colors? So one of the ways that was shown was this. We see that we've got the 5, term 1, and then term 2 is the bottom row and the second row together. That'll give us the 9. And term 3 is all 3 rows. That'll give us the 13. I'm curious here, what do you notice about the way this is arranged, how it's growing, and even the selection of colors? One of the things that were mentioned that was noticed is that there seems to be an array that's showing up here because there's this addition of 4. So there's addition of 4 each time, except for the one that sticks out because the first term is 5. So that idea of students are used to at this point, potentially in grade 4, they're exploring this idea of pattern rules. It starts with 5, adds 4 each time. When it's shown in a concrete way, actually represents something that is helpful when we're looking at a task where we're predicting far. So without any further ado, we're going to jump into our next prompt. Oh, wait, before we jumped into our next prompt, we actually had this way of presenting, which is a new. That idea of ordered pairs is a new concept for grade 4s and grade 5s sometimes, depending on where the gaps are. So we are looking at how do you represent this pattern through this model as well. How might you move things to represent so we've got ordered pairs of 1, 5, 2, 9, 3, 13. What's happening as you move it. So this is a representation that showed up. So we see that that is a growing pattern. We can see that the line is growing. We can see it's a steeply growing pattern from what we see because it grows every step it takes, it goes up 4. So it's a very steep set of steps that we see, and those steps show us how that pattern is growing. So it's important that this is a way that we are helping students present patterns concretely and graphically on a graph. Our next activity is going to look at how might you determine the value of the term 25. How might you determine that value using some of the concrete representations we have. So we'll give you a moment to think about that, try that out, and we'll jump back in. Okay, so looking at this far prediction of 25, one of the things you will notice is students want to do repeated addition. They want to add 4 each time and keep going because it doesn't take a lot of thinking. It's mechanical. I don't have to worry about it, but it's very inefficient. It's very hard. Let them do it the first time to see how hard it is and give them something that's really far away. Maybe you're going to give them the 40th term as a task. And then help them pause and think, how can I use this concrete representation to help me do this in a better way? So one of the ways that showed up is this. So we've taken a very familiar concrete set. We notice that we start with 5, we add 4 each time. But that connection to repeated addition is we're taking them from additive thinking to multiplicative thinking using this concrete representation. So term 1 has 1 column. It tends to have 5 in it. Okay, that's fine. We'll leave that. We'll notice that we've changed that top one to blue intentionally afterwards, but students won't do that right away, right? Term 2 has 2 rows. Term 3 has 3 rows. But what we notice here is, like, as we go on to term 4 and 5 and so on, 2, 3, 4, 5, that each time there's 4 added, which means that there's always rows of 4. So term 3 has 3 rows of 4 plus the 1 blue tile. Term 2 has 2 rows of 4 plus the 1 blue tile. Term 1 has 1 row of 4 plus the 1 blue. So that helps make that connection from additive thinking, plus 4 each time, to multiplicative thinking, where I can take a term number. Term number 3 is going to be 3 times 4 plus the 1 bonus. So term number 25 would be 25 times 4 plus the 1 bonus from the beginning. So we want students to get to this connection through many experiences. It's not going to happen in just one lesson, but we want them to continually experience that using concrete representations and leading them towards multiplicative thinking is crucial to build their understanding. All right, so now we're just going to jump back into the main group and continue with some Q&A.
So after our breakout rooms, we came together as a group to discuss a quick Q&A based on the questions that we had pulled from the Slido submissions. We received some requests in the Slido poll related to resources that are ready to go for students. As a response to these requests, we tried to pull together a folder of Google Slide manipulatives along with today's tasks, with the idea that you might make a copy of and use these with your class. And you might reuse them by copying and pasting a task across the top and make use of the same manipulatives. We also did our best to adjust the format of the tasks that we had participants explore in the breakout rooms in the hopes that they could easily be duplicated and reused with similar prompts or patterns for students to engage with. The idea of students representing with tiles might be the type of task that you return to multiple times across a learning cycle. And we were hoping that substituting out those prompts with some of the prompts available in the long-range plans might help with some grab-and-go lesson resources. One of the challenges of responding to these Slido questions is that we don't have a name to connect with one-on-one or to clarify with. So we did discuss the idea that this maybe isn't what people were hoping for. And we did want to suggest that if there are any specific templates or tools that you're looking for in a digital format, or just something else that we didn't supply today, please don't hesitate to reach out to us via email, and we'd love to either help you out and co-create those with you, and adding them into that shared folder would be a great way for everyone to benefit from that conversation.
The other piece of this is also those who have access to MathUp. MathUp has a lot of different digitizable content that you can put right into, present into your class as part of your Minds On or your action task right in Google Meet. So that's a huge resource as well. So one of the questions also connected to MathUp was also around the lessons just for grade 6 don't seem to cover the new expectations. When will this be updated by MathUp? So some of the way in which MathUp is doing their updates is kind of confusing. So we're just going to walk through where you find this really quickly. So this is the MathUp website, the landing page. If you go to grades and you click on the grade that you want, or any of the grades really, you'll get this window at the top of the grade planning board page. That'll give you this. This is kind of how they're updating kind of each of the new topics. Now, it's important to note in the math long range plans that WRDSB has provided, we are using the old units down here, right? That's important because you'll find in your grade 4 class there's some grade 3 lessons that are listed and so on and so forth. So this is where you'd scroll down and find that content for each grade. But under each grade, this new top piece that they've provided updates on the 2020 curriculum, you see what they've done that's completely new. These are topics that are new in the 2020 curriculum. Not only that, but some of them they're starting to shuffle content that's not necessarily new curriculum, but it's been shuffled down to a different grade. So those are the two ways they're updating things. It's kind of confusing, to be honest. So I wouldn't follow the MathUp pathways that they're giving you for 2020 because that's completely different from our long-range plans. But the way you'd find the lessons for that would be going through the old content. As our year progresses, we will be hitting those new ideas, new concepts that are strictly 2020. Big examples are the coding, financial literacy, things like that, and they will be updating those, and we will list them under the topic page for you to look up under in MathUp. So hopefully that addresses the way they're doing their progress as best as we can understand. It is a bit confusing though. It's hard to find things. So I want to switch back to our Q&A for that. So thank you for joining us. We really appreciate you taking time to engage with topic 2 patterns. We are very hopeful that some of the ideas discussed are going to be useful for you as you progress through this topic with your students. Now, we do have these resources will be made available for you via the Elementary Math Google group and the Just-in-Time Math PD site that is posted in that link that is posted in Google group as well. Along with these resources we've used for today, so manipulative sets, some Desmos graphing calculators, interactive tiles, visual patterns, all those things will be available to you as well. So thank you so much. We appreciate your time, And we'll see you back for topic 3.